Yeah, this is the last part of the demonstration. That is the management of rules and constraints and partial evaluation that creates more efficient versions of these rules and constraints. You see here in this graphical view our product type, which is a power type of product. Never mind that this symbol is a little bit different because I use a different graphical palette for this. We have an object MLT Taylor's rules that contains all the axioms and rules and constraints defining MLT Taylors within Taylors. This is the a part of the definitions of subclassing in MLT Taylors. So if you have a type T1 that specializes T2, and if you have an instance of T1, then it's also an instance of T2. Yeah, this car specializes product is an example of this specializes predicate, and by inserting that into this more generic formula, we can generate a more efficient formula with less variables. So T1 is replaced by car, T2 is replaced by product, and then the formula becomes for all E in car, E in product. And that is exactly deriving this instantiation link from my car 1 to 4 to product. Now, if you have another class like mobile phone that is having the power type product type, then a similar uh, rule will be generated for all E slash mobile phone, E in product. So that will also then be derived. Let's have a look at the textual representation of car. Oh, that's not so interesting, but I wanted to see the textual representation of product. Make it a bit larger. Yeah, and that is this generated rule. So for all E in car, E in product. This generated rule has just two levels. This is the class level, car and product, and the variable ranges over instances of these classes. So this is a two-level rule. Let's have a look at the definition of MLT Taylors. Oh, that's all these rules. Let's make it a little bit bigger. Yeah, and here you see some of these rules. For example, specializes is reflexive. All types specialize themselves. If something is an explicit specialization of something else, then we use this specializes one, that it means direct specialization. Let's see. Yeah, here we have our generic rule that we talked about before, this D3 rule, that is this one here. So if T1 directly specializes T2 and E is in T1, then E is also in T2. T6 may be interesting if T1 is a power type of T2 and T3 is an instance of T1, then T3 specializes T2. So this is used to derive specializations from instantiations. That is the core of the power type implementation of MLT Taylors. The rest here is on complete and disjoint categorization. Now we also have some constraints. So individuals may not have instances. individual may not be types, and some more constraints on categorizations. Yeah, that completes the demonstration of multi-level modeling with ConceptBase. Links to the different parts are on the web page here. So conceptbase.sourceforge.net/er21 demo. Many thanks for listening, and if you have questions, don't hesitate to contact me under the email address in the paper. Thanks a lot and bye.